This is chapter 4, quadratic equations of class 10th. So in the previous chapter or chapter 2, we have studied various types of polynomials, and one was ax square plus bx plus c. Now this is called as a quadratic polynomial. When we equate it to 0, so this is just a polynomial, and when we equate to 0, this becomes a quadratic equation because of this equality sign. Now various situations will come up, we'll see in the examples also, when this becomes very important. Just assume that we wish to, or say a charity trust wish to build a prayer hall having a carpet area say 300 meters square with its length 1 meter more than twice its breadth. So if we take x as the breadth, then the length would be twice of this plus 1. So the length would be this, if we take breadth as x, the length would be 2x plus 1. Now we know for a rectangle, length into breadth is equal to this area. So 2x plus 1 into x is equal to 300. So 2x plus 1 into x, multiply x inside, 2x square, then x, 2x square plus x is equal to 300. Now take this 300 on the left hand side, you will get some equation like this. 2x square plus x minus 300, and this is the equation which is called as a quadratic equation. Many people believe that Babylonians were first to solve this quadratic equation, and they knew how to find this two positive number with a given positive sum and also the product. If the product and sum is given, they are able to find out these numbers. And this program or this problem is exactly equal to x square minus px plus q. P product, q sum, right? Then Euclid, the Greek mathematician, great mathematician, he developed a geometrical approach for finding out the lengths. Today we call it as quadratic equations. And solve or solution of this quadratic equation is also accredited to or credited to Indian mathematicians. In fact, Brahmagupta, he gave an explicit formula to solve a quadratic equation of this form, ax square plus bx is equal to c. And we'll see in later discussion, this is nothing but the Sridharacharya formula. We'll call it as quadratic formula. This is also quoted by Bhaskara too. And this is for solving quadratic equation by the method of completing the square. Then Al-Khwarizmi, whose name is used for algebra, the Arab mathematician, he also studied about quadratic equations. Abraham Bar-Hia Hanasi, in his book Liber Embedorum, he published in Europe this AD 1145. This also gave a complete solution of different quadratic equations. So we are going to study the quadratic equation and how they are important in our daily life, and we'll try to solve these in terms of roots. So quadratic equation, as we discussed, that you take any variable x. Why we take x? Because x is not very common in the alphabet in the sentence, so we generally take x as the variable. So this ax square plus bx plus c, this form is the quadratic equation, where this a, b, c, these are real numbers and a cannot be 0, because if a is 0, this will become a linear equation. So this equation of what we have discussed just now is a quadratic equation. All these are quadratic equation, and if we say, or in fact, any equation with degree 2 is known as quadratic equation. And this is a trivial tendency or traditional in terms, we follow the descending order. So this is good. This can be written like this: minus 3x square plus 4x plus 2. This can be written as minus x square plus say 300 plus 1. Let us make it 301. So we make it, or we write it in the descending power of the x. And this is the standard form of a quadratic equation. We'll take some examples. we need to represent these situations mathematically. John and Jivanti, they were having 45 marbles, and both of them lost 5 marbles each, right? And the product of the number of marbles they have now is 124. So if John is having, say, X marble, of course Jivanti would be having 40, or Jivanti would be having 45 minus X, because the total has to be 45. If you add them, just add them, you'll get 45. So X, if it belongs to, say, John, then Jivanti has to have 45 minus X, and both of them lost 5. So X minus 5 and 45 minus X minus 5. This is X minus 5 when John lost, and 45 minus X minus 5 when Jivanti lost. Now one more situation is given, that the product of the number of marbles they have is 124. So X minus 5 into this 40 minus X, 45 minus X minus 5 is 40 minus X. X minus 5 into 40 minus X is 124. And we would like to find out how many marbles they had to start with. So for X minus 5 into 40 minus X, multiply it. You'll get, how you have to multiply? X into 40, 40X. X into X, because minus is there minus X square. Minus 5 into 40, that is minus 200. Minus 5 into minus X is 5X. So this is your equation. We have just tried to write it in descending form, and this is of course equal to the 124. So take 124 here, this equation becomes like this. And we generally don't take minus here. So we multiply whole equation by minus 1. So the equation would be x square minus 45x plus 324. So this is the quadratic equation which this problem represents. Now the second situation is, a cottage industry produces a certain number of toys in a day. The cost of production of each toy was found to be 45 minus the number of toys produced in a day. So if X are the number of toys, then the cost of production is 55 minus X. This is given. On a particular day, the total cost of production was 750. So X into 55 minus X is equal to 750. This situation is given. We would like to find out the number of toys produced on that day. So the situation is like this. If the number of toys is X, the cost of production as given in the question or the situation is 55 minus X. And the multiplication of this gives the total cost of production. And on a particular day, X into 55 minus X is equal to 750. Multiply it, 55X, this will become minus X square. This is 750. Take 750 here, this will be minus X square plus 55X minus 750. Multiply whole by minus 1 because we don't want minus 1 here. We generally don't keep it. So X square minus 55 plus X plus 750. This is our quadratic equation. Now we need to check whether these equations are quadratic equation or not. So you have to have some X square stuff. X square should be there. So X minus 2 whole square, just expand it. A square plus B square minus 2AB. So X square minus 4X plus 4 plus 1 is equal to this becomes X square minus 4X plus 5. On the right hand side we have 2X minus 3. Take 2X and 3 here. So let us make it X square minus CX plus 6X plus 8. And this is actually representing the form of AX square plus BX plus C. So this is our quadratic equation. Let us take the second one. This is the left hand side. So X square plus X, this one, plus 8. And the right hand side is A plus B, A minus B. So this will be X square minus 2 square, that is 4 square, 4. Equated, this gets cancelled. You will get X plus 12. X square term is not there. This is not a quadratic equation. Then again, the left hand side for the third part is X into 2X plus 3. Multiply it, 2X square. Multiply it 3X, so 2X square plus 3X. Equate it with X square plus 1. So X square plus 1, so just take these on the left hand side. You actually get an equation which is of the form AX square plus BX plus C. So this is the equation which is a quadratic equation. Again, X plus 2 whole cube, you know the formula of whole cube. So just expand it, X cube plus 6X square plus 12X plus 8. Actually it is A cube plus B cube plus 3AB A plus B, 3AB into A plus B. And now this actually has to be equated with X cube minus 3. X cube get cancelled. 4 can be taken this side. This is again representing the quadratic equation. one thing I would like to highlight here is this equation is represented like this. Why? Because we know that we have 6 in common, and we know that this can be written as, you just take 6 common, 6 into x square plus 12x plus 6x square plus 2x plus 2 equal to 0. Now 6 cannot be 0, so this has to be 0. So that is why we always represent this equation in the minimum terms. So x square plus 2x plus 2, this is of the form ax square plus bx plus c, hence it is a quadratic equation. Now let us solve quadratic equation by factorization. This 2x square minus 3x plus 1, if we just replace x by 1, just place x equal to 1, you see that this equation becomes 0. This is the what you wanted. This becomes 0, that is of the right hand side. So this has become 0. That means x, if place 1, that is x minus 1 equal to 0. This is the factor. This is the factor of this equation. So that is how we will make the factor. So x equal to 1 means if we take this x, or say alpha equal to 1 is as alpha. So any alpha which is satisfying this ax square plus bx plus c, when we place alpha in the place of x. So a alpha square plus b alpha plus c, this is called the root of the equation. So x is equal to alpha is the solution of this equation. Alpha is going to satisfy the quadratic equation as one does here. And you have to see that the equation we just discussed in the chapter 2 when we were discussing polynomials, the zeros of this equation are nothing but the roots of this equation. At that time I also discussed that we are going to shortly talk about the roots. So these are the roots here. Let us find the roots of this equation. 2x square plus minus 5x plus 3. Now this 2x square minus 5x plus 3, we have to write minus 5x such that we get some kind of factorization, and this minus 5x has to be of these two multiples. So minus 5x has to be, because on the right hand side you have 2x square, means this one 2x square and 3. So this is, what is this? 6x square. So when we represent these minus 5x in some addition or subtraction term, the multiplication of this term has to be 6x square. So how we can write this minus 5x? Minus 5x can be written as minus 2x minus 3x. These two are equal. And in this case, minus 2x into minus 3x is nothing but 6x square. So this will satisfy our situation. So minus 2x and minus 3x is equal to 6x square. This is exactly equal to this 2x square into 3, these two multiplication. So this has to be written in some form so that the multiplication of these two terms which we are adding or deleting or subtracting has to be equal to these two multiplication of these two. So 2x square minus 5x plus 3 can be written as 2x square minus 2x minus 3x. Now you will ask why we have not written it as 3 minus 3x minus 2x. This can also be written because this also becomes minus 5x. Just because we want to take something common. You will realize just now. 2x square minus 2x, just take 2x common from these two. You will get x minus 1 inside. You take 3 from minus 3 common here, you will get x minus 1 inside. So when you take x minus 1 from these two, you will get 2x minus 3 inside. So you will have x minus 3 into 2x minus 3. That is how you come up with the roots or the factors. Now these are the factors. So either this has to be 0 or this has to be 0. Say x into y equal to 0. What do you say? X has to be 0, or either x has to be 0 or y has to be 0. So now what we can do, we can place 2x minus 3 equal to 0 and x minus 1 equal to 0. So this becomes x equal to 3 by 2. This gives x equal to 1. So these are the solution of the equation. 1 and 3 by 2 are the roots of this equation. So we can also verify, just place these in these two, and in this equation you will get the answer. We will get it as 0. Now we have to find out the roots of the equation, quadratic equation 6x square minus x minus 2. As I said, this has to be written minus x, so that though these two terms which makes minus x, when they are multiplied, they have to be equal to 12x square. So how we can write? We know that 4x and 3x, this will give you some minus x. 4x and 3x also multiplied gives you 12x square. So this minus x, how can you get it? 3x minus 4x. So this is going to be minus x, right? So we have written like this just because we want to take some 3x out. So when we take 3x out from this, we get 2x plus 1. When we take minus 2 from here, we again get 2x plus 1. So we are interested in this common term because we take 2x plus 1 common. 3x minus 2 is left. So 3x minus 2 into 2x plus 1. This is the factor of 6x square minus x minus 2. Right? So when we equate these two equal to 0, either this has to be 0, this has to be 0. So this gives x equal to 2 by 3. This gives x equal to minus half. And these two are the roots of this equation. You can place it in this, you'll get 0. One more equation is this 3x square minus 2 root 6x plus 2. Now this minus 2 root 6 has to be written in some form, so that means in two terms such that the product of what we have written has to be equal to 3x square into 2, that is 6x square. So this minus 2 root 6 can be written as minus root 6 minus root 6, right? And if you multiply it, you will get 6x square. So minus root 6 minus root 6, 6x. So you get 6x square. So this minus 2 root 6 can be written as minus 6x minus 6x. Why we have written here? Because we can take root 3x common here. You'll get root 3x minus root 2. You can take root 2 common here. You'll get root 3x minus root 2. These two terms now can be taken outside, or this factor can be taken out. Inside you'll get root 3x minus root 2. And you see that these two are exactly equal. And when we equate it to 0, you'll get x equal to root 2 by 3 in both the cases. So there are two roots which are equal. So this equation has two roots which are equal, under root 2 by 3. Now we have discussed about the prayer hall in the beginning of our discussion. So let us solve it. 2x square plus x minus 300. Now 2x square into this 2x square into 300 multiply it, you will get some 600x square. So you have to make this x such that these two which will give us 600. So 24x and 25x, if you subtract, say do this, these two will multiply to 600x square, and we will solve a problem of getting minus x also, plus x also. So 2x square minus 2, this can be written as minus x can be written as minus 24x plus 25x. So now 2x square minus 24x, you take 2x common here, you take 25 common here, x minus 12 into there. Now take x minus 12 from whole of these, you will get 2x plus 25 inside. Now equate it, x equal to 12 or x equal to minus 12.5. And we know that the dimension cannot be in negative. So this is 12 and the length is 12. The breadth will become, the breadth has come 12. The length will become 2x plus 1, that is 25. Now let us solve the quadratic equation by completing the square. How are you going to get this? Let us consider a situation. The product of Sunita age is 2 years ago. Means if the Sunita age is x, 2 years ago it will be x minus 2. So the Sunita age 2 years ago and her age 4 years after means x plus 4. 4 years after. So now is 1 more than twice her present age. So that will be twice plus 1 means 2x plus 1. What is her present age? So the product of 2 years back after 4 years, the product is equal to twice 1 added to the twice. So now equate it, just multiply it, you will get x square minus 9. This is the quadratic equation. Now one thing becomes very predominant here. This equation is x square minus 9 equal to 0. So this is actually x square is equal to 9. So this gives solution as minus 3 because minus 3 square is equal to 9 and 3 square is also equal to 9. So you get solution as plus 3 and minus 3. These both are solution. But because the age cannot be negative, so we have taken x equal to 3. So Sunita present age is 3. Again let us get a situation. X plus 2 whole square minus 9. So you can equate, means take 9 on that side. So x plus 2 whole square equal to 9. So x plus 2 is equal, in this both case, this 9 can be written as 3 square, but it can be minus 3 square also. So one will equate x plus 2 equal to 3 and one will equate it to x plus 2 equal to minus 3. Once it will give you x equal to 1 and the other time it will give you x equal to minus 5. So these are the two roots of this equation. Now let us take one more, x square minus 4x minus 5. And you know, if we solve this equation, it will actually give you x square plus 4x minus 5. So our key idea is to make this equation like this. So this is how we are discussing about solving a quadratic equation by completing the square. So if we can write this equation in this form, so this is a square form, you can easily get the solution like this, right? So how we are going to go solve it? Let us understand how we are going to get this. Just consider this situation, x square plus 4x. Just concentrate on this. We'll talk about minus 5 later. X square plus 4x. X square plus 4x. So what is exactly this is? This is x into x, say this area. 4x is say 4 into x. Just combine them. So this will be equal to x square plus 4x. This is x square. This is 4x. Combine that. Now this 4x can be divided into 2x and 2x. So this is one 2x part. This is 2x part, right? Now this 2x can be taken this side. So what this area becomes? This becomes x plus 2, and this becomes x. This is also x. This is also x. So the area becomes x into 2, x plus 2 into x. This one plus 2 into x, because this is remaining. So this becomes x plus 2 into x plus 2 into x. Now what we have done is we have added 2 into 2 and subtracted 2 into 2. This area we have added because we have added by ourselves. We have to deduct it also, subtract it also. So this becomes x plus 2 into x plus 2x. Again adding and deleting this. Adding and deleting, because this we don't want this, because this was not already there. Now this particular equation from this to this is nothing but x plus 2 whole square and minus, this is x plus 2, this is x plus 2, so this is x plus 2 whole square, and this is minus 2 square. So actually we have started with x square plus 4x, and we have come up to this situation here diagrammatically. This is how we make any equation as the square. So the process is like this. X square plus 4x, what you have done is you have divided 4x by 2, because a plus b whole square is nothing but a square plus b square plus 2ab. So this 2 has come, so we have to divide this term by 2. So this 2ab term has to be divided by 2, so it becomes 2x. We have to add 2x, means this is 2x. So how you can write 4x? Because you have to write 4x in terms of 2x. So 4x is 2x plus 2x. So this is 2x, this is 2x. Now this is x square plus 2x plus 2x. This we have taken x common. So x plus 2 into x, this remains like this. Now we have added 2 into 2 and we have subtracted 2 into 2. Why? Because we know that in 2ab form this is going to be x plus 2 whole square. So this is 4. So 4 we have added, 4 we have subtracted. Now in this scenario, what it has given us, you can take from this 2 common. So you get x plus 2. Again from this whole you take x plus 2 common. X plus 2, so again you get 2 plus x. So this is what? X plus 2 whole square, and this is nothing but 2 square. This was remaining, so it is 2 square. So this can be written in the form of, now 5 was remaining, so you have to subtract 5. What is this? Minus 4 minus 9, this is minus 9. So x plus 2 whole square minus 9, and this is nothing but x plus 2 whole square minus 3 square. So this can be written like this. This is how we do, or this is the method of completing the square. So how we can briefly describe this? X square plus 4x, what you have to do is make this x plus x square plus 4 by 2 whole square and minus this 4 by 2 whole square. This will give you exact idea. So this can be written, because minus 5 was also there. X square, when we add this, we get minus 9. So x plus 2 whole square minus 9 equal to 0. Now this is again a situation, 3x square plus 5x plus 2. Now here, what was the reason? In this, the coefficient was 1. So 1 square is 1 only. But here the situation is somewhat different. 3x square minus 5x plus 2. How we are going to make it a perfect square? This has to be root 3x square, then only we can get 3x square. So how can we make it? Just multiply whole by 3. So we have multiplied this equation by 3. So now 9x square minus 15x plus 6. 9x square minus 15x plus 6, as we know, this becomes 3x square, And now this 15x can be written as 2 into 3x, because 3x is our this term. 2ab is nothing but minus 15x, a square plus b square plus 2ab. So 2ab is minus 15x. This we have to see. Now we know that we have made 9x, that is, this is 3x square, so a is 3x. 2 into 3x into b equal to minus 15x. Cancel it out. Okay, take 3 here, take 2 also here. So what we get? We get b equal to 5 by 2, and that is minus 5 by 2. So b is nothing but 5 by 2. So that is 3x square minus 2 into a into b. 5 by 2 has come from here. 5 by 2 plus 6. Now 5 by 2 has to be, because this is b, so you have to add this and subtract this, only b. This has become 3x minus 5 by 2 whole square, and now this 25 by 4 has to be added with 6, and this becomes 1 by 4. This is how you get the square. Now this can be written as, you take 1 by 4 here, this is nothing but 1 by 2 whole square, right? So 3x minus 5 by 2 is equal to half for the first time, and as I said, minus half whole square is also 1 by 4. So you have to take 3x minus 5 by 2 equal to 1 by 4 on the next iteration. So first we get x equal to, at first go we get x equal to 1, and second time we get x equal to 4 by 6, that is nothing but 2 by 3. There is another process also if you want to solve. If you are interested in not multiplying, then you can divide whole by 3. So you get x square minus 5 by 3x plus 2 by 3. In this, what you have to do, x minus half of this term, x minus half of this term whole square, minus of half of this term you have to subtract, because this you have already added inside. Now this becomes x minus 5 by 6 whole square, this is 2 by 3, this is minus 25 by 36. You add this, you get minus 1 by 36, that is 1 by 6 whole square. So x minus 5 by 6 whole square minus 1 by 6 whole square. So this equation becomes this. You equate it with 1 by 6 one time, you equate this by minus 1 by 6 one time. So you get answer as 1 and 2 by 3. So let us take few more example. 2x square minus 5x plus 3. So this is not a perfect square, so you have to divide it by 2. X square minus 5 by whole by 2. So x square minus 5 by 2x plus 3 by 2. Now you know that x minus 5 by 4 whole square, this one, you have to subtract this 5 by 2 by 2, that is 5 by 4. So you have to subtract this, and now add this becomes square, perfect square. You add these two terms, that is will be equal to minus 1 by 16. So x minus 5 by 4 will be equal to 1 by 16. One time you equate it with the 1 by, because 1 by 16 is what? 1 by 4 whole square. So x minus 5 by 4 will be equal to 1 by 4 one time. X minus 5 by 4 will be equal to minus 1 by 4 at one time. So you get 3 by 2 and 4. So you can verify also. You can place this equation or these roots here, and you will see that it will be 0. Now the roots of the equation 5x square minus 6x plus 2, again 5x square is not a perfect square. You can do it in both ways. You can multiply by 2, so you get 25x square minus 30x minus 10 whole equation. This becomes 5x square. This is your a. Now you see that 30x can be written as 2 into 5x, so you get a, and b is 3. So this b has to be added, this has to be subtracted. Minus 10 remains here. This becomes 5x minus 3. From this point to this point, this becomes 5x minus 3 whole square. These two added, this becomes 19. Take 19 here. So 5x minus 3 has to be equal to 19 one time, under root 19, because this is 19, so it is actually under root 19 whole square. 5x minus 3 has to be equal to plus root 19 one time, and it has to be equal to minus root 19 one time. So you get these two solutions, and we will talk about this because we are going to the Sridharacharya formula just now. Again we have 4x square plus 3x plus 5 equal to 0. You can do, because this is already a perfect square, so this is 2x square, so you get a here, and this can be written as 2 into 2x into 3 by 4, so you get a you get a b, so you have to add b, you have to subtract b, and this is plus 5, so this becomes 2x plus 3 by 4 whole square, this becomes 71 by 16. Now here a situation has arisen. What? 71 by 16, if we place it here, we get a minus here, and no square can be equal to minus 71 by 6. So we say that if this square equate to any minus value or any negative value, which is not possible, so this equation is having no real roots. There are no real roots. So this is ax square plus bx plus c. We will talk about this because this will lead us to the quadratic formula or Sridharacharya formula. So I'll stop here now and we'll be discussing the quadratic formula in the next discussion. Till then, thank you so much. Take care of yourself.